Precision engineered customized flawed NDT specimens for advanced inspection, training and qualification. In today's industrial world, safety, reliability and quality assurance are more critical than ever before. Industries such as oil and gas, petrochemical, power generation, aerospace, heavy engineering, manufacturing and infrastructure operate under extremely demanding conditions, where even a small defect can lead to major operational failures, production losses, environmental hazards, or safety risks. To prevent such failures, industries rely heavily on non-destructive testing, commonly known as NDT. NDT plays a vital role in detecting hidden defects and evaluating the integrity of materials, welds, components, and structures without causing damage to the inspected object. But successful inspection is not dependent only on advanced equipment. It depends on three critical factors: skilled inspection personnel, qualified procedures, and realistic training environments. And this is exactly where technically engineered flawed NDT specimens become extremely important. Welcome to URGS International Engineering Services Pvt, a trusted manufacturer and global supplier of precision engineered, customized, flawed NDT specimens developed for advanced inspection training, procedure qualification, competency assessment, and performance demonstration. At URGS International Engineering Services, we specialize in manufacturing technically reliable specimens that simulate actual industrial discontinuities and real-world inspection challenges. Our mission is to bridge the gap between classroom learning and practical industrial inspection requirements. In this video, we will discuss the importance of flawed NDT specimens, various NDT methods supported, types of defects manufactured, technical manufacturing capabilities, industrial applications, procedure qualification requirements, and how customized specimens improve inspection competency and reliability. So let us begin. In many training environments, inspectors learn theory, equipment operation, and scanning techniques. However, real industrial inspection conditions are significantly more complex. Actual weld defects and material discontinuities behave differently depending on defect orientation, defect depth, geometry, material properties, surface conditions, weld profile, signal response characteristics, and inspection methods used. A technician who has only theoretical exposure may struggle to correctly identify and interpret actual field defects. This is why realistic flawed specimens are essential. A properly engineered NDT specimen allows technicians to experience actual inspection conditions before entering live industrial projects. These specimens help inspectors understand real ultrasonic signal behavior, defect sizing techniques, TOFD diffraction patterns, PAUT imaging responses, radiographic indications, magnetic particle leakage fields, penetrant bleed out behavior, eddy current signal variations, and visual inspection challenges. Without realistic training specimens, competency assessment remains incomplete. That is why flawed specimens are widely used for NDT training programs, ASME qualification preparation, PCN certification training, ISO competency assessment, employer-specific training, procedure qualification, performance demonstration, equipment validation, research and development, inspection reliability studies, and advanced inspection technology evaluation. At URGS International Engineering Services, every specimen is manufactured with controlled flaw characteristics and dimensional accuracy to ensure repeatability and technical reliability. Now, NDT methods covered. Section 2. URGS International Engineering Services manufactures customized flawed specimens for multiple conventional and advanced NDT methods. Let us understand these methods individually. Ultrasonic testing (UT). Ultrasonic testing is one of the most widely used volumetric inspection techniques in industrial applications. UT uses high frequency sound waves to detect internal discontinuities. For effective training, UT specimens must contain realistic internal defects that produce accurate ultrasonic responses. Our UT specimens may include lack of fusion, lack of penetration, cracks, slag inclusions, porosity, laminations, corrosion defects, embedded discontinuities. This specimen help technicians practice angle beam scanning, defect interpretation, signal analysis, depth calculation, beam path understanding, DAC and TCG evaluation, and flaw sizing techniques. Then next, phased array ultrasonic testing PAUT. Phased array ultrasonic testing is an advanced ultrasonic inspection method capable of electronic beam steering and imaging. PAUT technology provides detailed visual representation of defects through sectorial scans and encoded imaging. However, realistic PAUT training requires highly engineered flaw positioning. At URGS International Engineering Services, we manufacture PAUT specimens with precisely controlled defect orientation and geometry to simulate real industrial weld conditions. These specimens are ideal for S-scan interpretation, weld imaging analysis, multi-angle inspection training, advanced flaw sizing, procedure qualification, and encoded scan validation. Then next is time of flight diffraction TOFD. TOFD is highly sensitive ultrasonic technique mainly used for crack detection and sizing. TOFD relies on diffraction signals generated from flaw tips. Therefore, flaw geometry and positioning are extremely important. Our TOFD specimens contain realistic crack type discontinuities engineered to produce accurate diffraction patterns. These specimens support crack sizing training, weld integrity assessment, procedure verification, performance demonstration, and advanced inspection qualification. Then next is radiographic testing RT. RT uses X-rays or gamma rays to identify internal discontinuities. RT specimens must generate realistic radiographic images that resemble actual industrial weld defects. Our RT specimens may contain porosity, slag inclusions, tungsten inclusions, lack of fusion, root defects, burn-through conditions, and weld profile irregularities. These specimens help technicians improve fill interpretation and defect recognition capability. Magnetic particle testing MT. MPT is used for detecting surface and near surface discontinuities in ferromagnetic materials. MT specimens are engineered with controlled crack type defects and surface discontinuities. These specimens help technicians study magnetic flux leakage, indication patterns, magnetization techniques, yoke inspection, and interpretation sensitivity. Then liquid penetrant testing PT. PT is widely used for detecting surface breaking defects. Our PT specimens contain finely controlled surface cracks and discontinuities used for penetrant sensitivity evaluation, inspection training, technical validation, and interpretation practice. Visual testing VT. Now, VT is the first and most important quality control activity in fabrication and welding inspection. VT specimens may contain undercuts, excess reinforcement, misalignment, incomplete fusion, surface cracks, weld profile defects, spatter, and fabrication irregularities. These specimens improve weld quality assessment capability. Now eddy current testing ECT. ECT is commonly used for conductive materials and heat exchanger tube inspection. Our ECT specimens may contain surface cracks, conductivity variations, corrosion thinning, tube defects, and artificial notches. These specimens support signal analysis and probe sensitivity evaluation. Now section 3. Types of defects manufactured. One of the most important aspects of any NDT specimen is flaw realism. At URGS International Engineering Services, we manufacture both artificial and natural discontinuities. Artificial flaws are precisely machined or engineered for repeatable inspection response. Natural flaws are generated using welding processes, thermal methods, or controlled fabrication conditions to simulate real industrial defects. Let us understand some common defects. Crack defects. Cracks are among the most critical defects in industrial components. Specimens may contain surface cracks, embedded cracks, fatigue cracks, sheet-affected joint cracks, stress corrosion cracking simulations. These are widely used for UT, PAUT, TOFD, MT and PT applications. Lack of fusion. Lack of fusion is a planar discontinuity occurring between weld metal and base material. It is highly critical because it can significantly reduce weld strength. LOF defects are commonly used for UT, PAUT, TOFD and radiographic interpretation studies. Now porosity. Porosity occurs due to gas entrapment during welding. Specimens may contain cluster porosity, scatter porosity, linear porosity, fine gas pores. These defects are important for RT interpretation training. Now slag inclusions. Slag inclusions are non-metallic discontinuities trapped during welding. They create characteristic responses in ultrasonic and radiographic inspection. Then laminations. Laminations are base material defects commonly found in rolled plates. They are highly important for UT training and plate inspection applications. Then corrosion defects. Corrosion related specimens may simulate pitting corrosion, wall thinning, erosion corrosion, general corrosion, flaw assisted damage. These specimens are highly useful for oil and gas and refinery inspection applications. Then specimen configuration. Different industries require different specimen geometries. This is why URGS International Engineering Services manufactures multiple configuration pipe weld specimens, widely used in pipelines, refineries, power plants, petrochemical facilities, available in multiple diameters and thicknesses. Plate weld specimens, used for fabrication industries and structural applications. Nozzle configurations, designed for advanced PAUT and TOFD training. T-joint and structural welds, used for structural fabrication inspection practice. Custom geometries. Special applications can also be developed according to client drawings and technical requirements. Then section 5. Material capabilities. Material behavior significantly affects inspection response. Our specimens are manufactured using carbon steel, stainless steel, duplex stainless steel, aluminum, alloy steel and exotic alloys. Different materials produce different ultrasonic attenuation, magnetic properties, conductivity responses, and radiographic absorption characteristics. This helps trainees understand realistic industrial inspection conditions. Now, procedure, qualification, and performance demonstration. Modern industries increasingly require well-dated inspection procedures and proven technician competency. Procedure qualification ensures that an inspection technique can reliably detect defects. Performance demonstration ensures that technicians can successfully identify flaws under specified inspection conditions. URGS International Engineering Services manufactures qualification specimens according to ASME codes, API standards, ISO requirements, EN standards, client specifications, employer-specific requirements. These specimens support procedure validation, technique optimization, sensitivity studies, scan plant verification, equipment evaluation, and competency assessment. Reliable qualification specimens directly improve inspection quality and industrial safety. Now, Section 7. Industries served. Our customized flawed specimens support multiple industries. Oil and gas industry used for pipeline inspection, shutdown activities, refinery maintenance, pressure vessel inspection, offshore structure inspection. Petrochemical industry supports corrosion monitoring and weld integrity assessment. Power generation, thermal and nuclear power plants require highly reliable inspection systems. Aerospace industry, aircraft structures demand extremely high inspection precision. Manufacturing and heavy engineering supports quality assurance and welding inspection training. Similarly, research and development, used for technique development, software validation, probe studies, signal analysis, and advanced inspection research. Now, Section 8. Why choose URGS International Engineering Services? See, choosing the correct specimen manufacturer is extremely important. At URGS International Engineering Services, we focus on technical precision, realism, and industrial relevance. Our strengths include precision flaw engineering, realistic industrial simulation, advanced fabrication capability, customized engineering solutions, multi-industry expertise, technical understanding of inspection science, controlled flaw positioning, reliable repeatability, global supply capability. Every specimen is manufactured with attention to detail and technical accuracy. Our objective is not only manufacturing specimens, our objective is improving inspection reliability and technician competency across industries. At last, as industrial systems become more advanced, inspection quality and safety expectations continue to increase. Technically engineered flawed NDT specimens are no longer optional. They are essential for training, qualification, procedure validation, competency assessment, inspection reliability, and industrial safety assurance. At URGS International Engineering Services Pvt, we remain committed to delivering precision engineered, customized flawed NDT specimens designed for real-world industrial inspection challenges. Whether your requirement involves UT, PAUT, TOFD, RT, MT, PT, VT, or eddy current testing applications, our engineering team is ready to support your technical requirements. For customized specimen development and technical discussion, please contact us. Our email ID is info@urgseng.com. Our mobile number is +91 7359458455. Thank you for watching. Please like and subscribe our channel.